on doing that. All right, so my sense is I've put out there to you guys, hey, do you want to do machine learning? And I've only had one person so far show with any enthusiasm whatsoever. Everybody else looks at me in a state of fear. Would you agree with that? So there we go. Everybody's in a state of fear. And our woman tells us not to panic. And I worked hard yesterday and today, and I have slides to show you what is done in lab 0, 1, and 2. And I've started making up your test questions, your homework questions. And my thinking is you won't have just 24 hours. You can have the whole 2 weeks or whatever we need to do it. So let me first tell you what I have in mind for the test questions so you can have in your mind what it is you need to do. All right. So our goal is to understand machine learning for regression. Regression is when it's the function learned is it takes in a bunch of x values and that are real values, and it returns a real value. So regression is about returning a real value. And our goal is to make lots of fun graphs. All right. So we will name some function that we want to learn, and then we're going to try to learn it. And we're going to learn it using the techniques learned here. We're going to build some neural net. And then for our first graph, since our goal is to make lots of graphs, our first graph is we fix all the variables here, x1 through xn. We fix all of them except 1. And then we plot x versus f, x versus y, right? See what it learns. Maybe we at the same time we plot on the same graph x versus the right answer, and we can just sort of eyeball see how well it does. All right. So the other thing is let's try doing that lots of times, right? We will repeat what we just did lots of time, and each time we attempt to do it, we will modify something in how we did it. We're going to have some parameter called the attempt parameter, which tells us how we're going to change it. So here's some ideas about how to change it. You can change what function you're trying to learn. You could change the amount of error that you introduce to the function as you're learning it. You could change anything about the neural net, how many levels it has, how many, I don't know, whatever, right? You could change anything about the learning process. All right, so here we have some parameter, and depending on the value of the parameter, what we just did will change, right? And then what will we graph? The horizontal axis will be this parameter, and the vertical axis will quantify some way about how well did it learn. All right, so we can see how modifying this one aspect of the thing will change what we're learning. All right, so now I just ran upstairs from trying to do this myself, and right, so I'm going to code it up, and everything I code up, I'll give to you. And now, then what will you have to do? You'll have to modify what I've done in your own creative way. You'll have to change some other parameters and plot some other graphs, and report what you've done. Right? Does that make sense?
Sir, would we have kind of something like a post condition that we would need to satisfy that, like some sort of measure that how accurate we are?
No, you are going to just try different things and see how well it works and report on it.
Well, how would it work? How would we know if it's even good or if it's bad? Like, I'm just
Well,
assuming that.
let's hold off on the questions until that just gives you a vague sense.
Okay,
I
sure.
mean, the vague sense is you specify some function that you want to learn. You produce data that is representing that you're going to train on that has some idea of that data, that function. Maybe you'll add some noise because your training data is not perfect. You'll try to learn on it. You'll see how well it learns.
Okay, thank
right?
you.
You'll see how well it learns, and you'll make various graphs, which sort of tries to understand how well it learns. And so I'm going to do all that for you once, and then you're going to, maybe you'll learn on different, try to learn different functions, or you'll try to learn different, make bigger or smaller neural nets. I don't know what you'll want to change. All right. All right. So before that was just to give you some idea of what our goal is. So let's continue here and try to teach you labs, as I say. In Cameroon, they've made up these labs 0, 1, and 2, and I have PowerPoint slides explaining them. All right, so the first thing is on our homepage, I've added some labs. So you could, when you leave here, see if they run for you, because maybe permissions are wrong, or maybe you need to get yourself a Google account, or maybe, I don't know. They're working for Chester and I, and maybe we have permissions that you don't have. All right. So you click on that, and what should it bring you to? It should bring you to my Google Drive that called machine learning, and it will have various labs. And there's lab 1 that you can click on. When I made this slide, it only had lab 1 in it. Now I think it has lab 1 and lab 2 in it. So you can click on them and you can play with them. All right. And when you click on them, you double click on them. Since you are within Google, I was very impressed how easy this is, right? We're all in Google. Oh, so in order to do this, you probably need a Google account. Hopefully everybody has a Google email address. So you click on that, and it should bring you into the labs, right? This is lab 1, so it should bring you into lab 1. And as these labs were made by friends of mine who, when we were doing the Cameroon thing, that's just, and then I'm going to tell you what this is a program called Colaboratory. It's as far as I know, it's a Google thing. It lets you write programs in Python. It lets you particularly run all the Google routines for machine learning. All right. So what you'll see when you open this is it has lots and lots of windows. All right. So up here is a window right there. That's a window. That's a text box. And this is a window that has code in it, right? So the green is a comment in the code, and the white is code, and down here is the output of the code. And you run the code by do I say that right? So at any point you can modify things, and the version that you have on your screen, when you open it up, you can modify it, you can run it, you can, but of course you can't save it in a way that's going to change the original. When you save it, it'll change your copy in your own personal drive. All right, so when I clicked on save, what it did for me is it saved it. See here, how did I save it? I went to the top of the page, just like you expect. On the top of the page, and then in the little corner, there's something called File, and you hit that, and it gives you a drop-down menu. I couldn't screenshot the drop-down menus because whenever I try to do a screenshot, the drop-down menus disappeared. But you just say File, Save, Copy, and Drive, and then you go over to. I use Chrome. Of course, Chrome is also Google, and in Chrome you click on those three buttons there, those little tabs that are there, and it brings you up to your Google Drive, right? And your Google Drive then will have, hopefully will have, there it is, COLAB workbooks, right? Here's the machine learning workbook that's in my drive. That is where you got your stuff from. And here's my ones that I've saved, right? So it'll save them in your Google Drive. Everybody good so far? And then if I go into my Google Drive, right? So I go into this directory, and there it says copy of Lab 1, right? Because remember, I was changing Lab 1. You weren't allowed to save it yourself, so you can save it as copy and drive, and it should have put in there copy of Lab 1 that you can play with, right? Everybody good? So seriously, holler if you think anything sounds confusing, and you'll have these slides to look over. All right, so now what do we know about these boxes? It's an interpretive window. So what does that mean? Is that you can type anything code you want in this box, and then you can run it. And you can either run it by clicking that little arrow up there, or you do Shift Enter, and it runs it for you. All right, and it gives you the output, right? So here's the output, right? So here it says my variable is this string, and then it's printing my variable, and it says it's the string that we have there, right? So it's running it, and you'll see if we go to a different window, right? Here in this window, I said my variable, and now in a different window, I'm saying print my variable plus, right, concatenating on a different string, fantastic, and it says, right, the old value with fantastic added, right? Does that make sense? Here I'm doing it again. I took my variable and I added 5 to it because my advice is you just try things and see what works. I've been writing code today, and whenever I get stuck, I Google Python, how do I know the length of an array? And it Google brings up how to do it, right? So anyway, here I try adding 5 to the string, and it complains, right? It complains that my variable is a string and you can add an integer to it, right? So, but here's, but then the thing about these variables is, right, we never declared them, and we can change them whenever we want. So now here I have a new window, and I'm going to just change the value of my variable to 5. So it's now an integer, right? It is whatever you stick in there, right? Are you good so far? How are you doing, Shanaz? Am I scaring the death out of you? No. All right. So let's see. So how do you add new cells? You on the top of your page is this thing that says plus code, and it gives you a new code window. If you say plus text, it'll give you a new text window. I found sometimes I have this thing which says copy to drive, and sometimes I don't. So that makes me a little confused, but When I have it, I do it that, and it gives me a copy to the drive. And when I don't have it, I have to go to File. All right. So here, what's the little check mark? The green check mark tells me that I've executed it, right? And the number inside of it, the 21, tells me the order I executed them. So you can see I executed this one, and then this one, and then this one, right? And the key is that the order that you execute things matters, but the order that these windows appear do not matter. All right. So for example, 19 set a value to my variable, and then 21 changed the value of the variable, and then 22 asked what the value of the variable is, and it's the last one that got run. Right? Does that make sense? All right. And then here is a new window that is doing something else, but it hasn't been run yet. Doesn't have a check mark, so it hasn't done anything yet. All right, everybody good with that? These are the windows. All right, so now let's learn about Python. And basically, it's so easy. It's just pseudocode like you would expect. And if you don't know how to do it, you Google it and it tells you how to do it. All right. So here you can have variables, and I've set these variables to be various values. And then I asked what to print the type of the variable. And you can see we have an integer and a floating point and a string. Here's double quotes in single quotes are evidently interchangeable. It doesn't matter which one you use, right? Here's a Boolean, here's a list. Curly brackets, I don't know why you'd want to use a curly bracket. I guess it's because you can get different indexes, right? Here, 1 index is A and 5 index is B. I don't think we're ever going to do that.
The last one is actually a dictionary.
It's a dictionary, that's the word, a dictionary. But when I ask what type it is, oh, look at that.
It's too long, yeah.
I got a 6 here. All right, so I should fix that. You think this has come up as dictionary. Good. I was wondering why it looked the same.
What's the error there? What mistake did you make?
Oh, here, variable 6, variable 6.
Oh, you don't.
Right?
Oh, okay.
I never asked about variable 7.
7. Oh, okay. It's
right?
a typo then.
Right. And this of course came below. I brought it up here so that we could map them. I'll try to remember to fix that. If you don't see I fixed it, remind me. All right. So now, one thing that's really important about Python is that the indentation matters. So here I have an if that's right. Here I have an if that this is indented, and here's the exact same code, right? The only difference is I've indented 2 lines instead of 1 line, and it right in this case, right? It says this fails, right? Because 30 is x is 30, so this fails, and so it doesn't print that line, but it prints this line and this line. Over here, it doesn't print either of those because they're inside of the if, and it prints that line, right? Does that make sense? So the bottom line is pay attention to your indenting. Does that make sense?
Yeah, that does.
All right, so here is just how you do an if, right? You need a colon at the end of there, but most lines don't need colons. And my impression is you need a colon when you're starting a new indent, when you need to indent further, right? And here we got if, else, right? You know how those kind of work in computer science? Here, it's kind of funny. I have an if, right? My variable is some string, and I'm asking whether machine appears in machine learning, right? This one down here, I got a not. right? If the type of my variable is not an integer. Seems pretty cumbersome to me. I wonder if exclamation mark equals also works. I got this from lab.
Yeah, it works as well.
It works as well. Oh, Chester. Hey, Chester.
Hey.
All right, because that not's kind of weird. All right, so now how do I define a list? And we need lists a lot in our world. Is you just say, well, we have brackets and we put various things in it. So here there are 3 things in this list, right? And so how are they indexed? They're indexed 0, 1, 2, right? Up to their 3 objects. So n is 3, n minus 1 is 2. So they're indexed 0, 1, 2. So if you print the 0th one, you get ABC. If you print the 2nd one, you get this tuple 5, 6, 7, right? Now here's the list of a list, right? So here I'm doing my list 2, just as we did up here. My list 2 gives you 5, 6, 7, right? And 5, 6, 7 is indexed 0, 1, 2. So we're asking for the first guy in that, and that gives us a 6, right? Everybody buy that? Oh, this is kind of cute for whatever it's worth. If you go minus here, if you go minus numbers, this is -1, -2, -3. So the -2 in the list is the same one up here, and the -2 is that guy there for whatever it's worth. All right. So, okay, what are we doing here? Is we're joining various things together, right? So, what we did in a previous slide, a previous square, is we defined list to be that. And so now I can add 2 lists together, right? This is a list and this is a list. And when right here, this list has this contents, right? So I add on, right here, my list equals my list plus that stuff, right? And that adds on these, it kind of concatenates them together, right? Here I had 3 objects and now I have 2 more objects, right? And I also can append something to my list. So here's my list appended with 1 object, right? And so here's my 1 object added in. One thing that should be noted is that this is object-oriented programming. So that means every object is, well, maybe 5's not, but any objects that's not sort of your base object is going to be an object, meaning here my list is an object, and objects, if you know, you guys, have you learned about object-oriented programming, Shanaz?
Yes, we did it in Java. We did it in 1022. Yeah.
Excellent. All right. So here's an object. And so it has data. There's data. And it has methods or procedures, right? So here, my list is an object. And you're appending this to that object, right? We're good so far?
Yes. Yeah.
You keep saying yes, Shanaz, because I want to make sure that you're a baseline. All right.
Okay. Okay.
All right. So here, we need to loop. All right. So the for is kind of a nice thing. The way for works is you have a variable. You have here. This is going to be a list, right? Range 10 will be a list, and this will be for all items I within that list. All right. So what, and then what are we printing? We're printing all the items that are in the list. So what range 10 is a list? It's a list from, what is the range here? Well, it goes from 0 to n minus 1, right? It's gonna, the key here is that a range will have 10 objects. Range 10 will have 10 objects, which will be 0 through 9, right? And so what our code here is doing is it's going through the I will be 0, 1, 2, 3 up to 9, and we print them, right? Does that make sense? So in this case, the range is 0 to 10, 4 to 10. So it's going to start, if this is I and this is J, it starts at the I and it goes to J minus 1. All right. And this is the same, except it does it in steps of 2. So here we started at 4, 6, 8. We didn't make it up to 10 because we stop when we get to 10. Right? Everybody buy that? But of course, you can have any strange list here whatsoever. Right? Here's a list of a string, an integer, and a Boolean. And when we do the exact same code as we did before, it prints them, right? Now, what did I put in this funny print line? Well, I'm printing the value I, and then I wanted a space between the i's, and then I wanted it all to fit on my slide. So somewhere I think in the lab it talked about, or maybe I Googled this one, I forget which. But anyway, I put this in and it said that means don't end the line, right? So it keeps giving end of line. While here I just said print I, so they came on different lines, right? Everybody good?
Yeah.
A while loop, I think is pretty obvious. There's nothing exciting about a while loop. Functions are kind of fun. In fact, I just changed my example here an hour ago because I made it more exciting. All right, so what do we have here is we're defining a function. All right, so I guess when you define something, no actions actually happen other than we're giving a meaning, we're defining the function, right? The function needs a function name. In this case, it's going to be multiply. And you can see here I'm defining function. Here I'm calling function with the same name, right? And then multiply is going to have 3 variables, right? And so here I'm calling it on those 3 variables, right? And this is what I just added because I love this. I've always done this in pseudocode, and I don't know why every programming language doesn't do it. It allows you to return more than one value, right? So here I'm returning the product of the first number and the product of the 3 numbers. And so when you call it, see here, when you call it, it returns 2 numbers. And so A, you can call it A comma B equals, and A gets the first number that's returned and B gets the second number that's returned. How glorious is that, right? But here's another way of doing it. Oh, so here I'm calling multiply, and right here I call multiply and I get A and B, and then I print A and I print B and I get the right answers, right? And then the second time I call it and it gives me sort of this, I don't know what a bracket things are, but anyway, it's not quite a tuple.
It's called a tuple. Yeah, it's called a tuple.
It's also a tuple?
That's what it's called, yeah.
Is there a difference between square and curly brackets?
Yeah, square brackets are a list and the round brackets are tuples.
Oh, of course. All right, so round brackets is a tuple. And so you see it returns my two values, right? The other thing that's interesting is the third number is optional. So here, when we called it, we didn't give a third number, and the default value was 1. So here, 3 times 6 is 18, and times the 1 is also 18. Right? People kind of understand this?
Yeah.
Yeah.
I understand it, sir, but the printing line statement, it said 3 times 6 times 2. Was that a mistake then?
Oh, yes. I'm gonna go with yes. Yeah, yeah. I mean, it's not a mistake in the running of the code. It's the mistake
Yeah, it's just
that
the
I changed my function so many times, and that is not what it's doing. I guess
Yeah.
it's really, it should be 3 times 6 times 1, because the
Yeah.
1 is coming from up there. Good catch. I'm not going to remember all these typos, but and the problem with cutting like this is it makes it harder to fix these typos, right? That's a pain too. All right, so now what are we doing here? Now you need to, often I find I run things and they don't work, and they don't work because you didn't import the libraries. All right, so here, what are we doing? We're importing the library called random, and then random's now a big object called the library, and it has various routines in it, right? So one of the routines in random is random integer, and surprisingly enough, it returns a random integer, right? And so when we print it here, 5, what's 5? It's a random integer. And then, right, so there's a method in it, and this is kind of fun. Instead of right, we imported this thing called Muppy, which I know is useful, and I haven't used it yet. But we rename it to NP. Why? Because we don't want Muppy everywhere. We want to have it be shorter. So this is just renaming the Muppy to be NP, right? And so NP, not only does it have a random function, but it has Muppy has a square root routine. All right, and then here we're going to import instead of importing all of math, we just import particular routines from math. And I'm just making this up, but in the example, they're no longer saying math plus cos, right? So now we can just use cos and pi by themselves without having to say math point. Makes it a little shorter. All right, figures. I played a little bit this morning. In my opinion, the lab 1 has somewhat teaches you a little bit more than I think you need to know. And so here's just I wanted the simplest way to make a plot possible. So here's how I made a plot this morning. Though, as I say, the lab tells you a number of different ways to do it. All right, so here we are importing this whole plot thing as, here's our object, PLT will be our object that knows how to plot things, right? So here we're putting them all these are routines of that plotting object, right? And then we get data here, and we ask the plot the X data versus the Y data. And how does that work? Here's our X data is 1, 2, 3, 4. So here our values are 1, 2, 3, 4, right? And then what are our Y values? Our Y values are those, and you see that they get, I guess my X data, my Y data better be the same length, right? Because it's plotting 1, 10, 2, 12, 3, 19, right? And then these are all optional. You don't have to add these if you don't want. You can change the size of the graph to be slightly bigger. You can add, right here I added a label here, a label here, and a label there, right? And here's something that's kind of fun, the semicolon. Oh, one thing, I had it in a slide earlier. Did I go over it? Here, this little thing down here, the last line of any window, if it's uncaptured, which I'm going to mean it's not put into a variable, right? Here I didn't I stated something here. Right here, this 5 is captured because it's put into this variable. But here, my variable plus 5, it's just kind of floating, not captured. And so it automatically prints if the last line is uncaptured, it prints it without a print statement. And that's kind of useful. But in where's my semicolon? Oh, here. There it is right there. It's not a semicolon, it's a colon. Right? What does it do? It suppresses this last thing here, I guess, is officially, though it does something, it's officially uncaptured because it's returning something that we're not doing anything with. And if you don't put the colon at the end, you get a bunch of messages that you don't necessarily want. So that suppresses that. All right. That was it for my whole teaching of Python. You are now experts at Python.
So
I have a question.
sorry.
Sorry.
Okay, so is this going to be enough for us for all the labs?
Well, there's a good question. I'm hoping that's all we're gonna need, right?
Okay,
And if we need
yeah.
more, then we will have tutorials and classes in which we will try to learn what we need together. The truth is, I did need some things just as I got up here. I needed to know what was the length of a list, and so I Googled it, and it told me to use len. It told me the length of a list.
So it'll just be something simple we can look up, but not anything like complicated. We can just look up if we need to look up something, right?
Well, I'm going to spend between now and Wednesday. Our next class is on Wednesday, right?
Yeah.
I'm going to code up my solution to your test, and if anything comes up that I think you need to know, I will tell you, and you can read over my code and see make sure you understand my code, right?
Okay.
So far, I haven't done anything too hard. All right.
Okay. Yeah.
All right. So now let's go back to machine learning.
Before
so
you go,
just
I have a question.
All right.
Yes, please.
Yeah. Ask it.
Can you go to the slides, the last slide of Python?
Yes. This one.
Oh, I just don't understand. You know how in X data it starts from 1 to 4, but then when actually plotting it, it starts from 10. Like those
Oh no,
numbers don't.
that killed me too. Sorry. They're decimal places in there. This is 1.0 and this is 1.5. I can't see it either, but
Oh, okay. Okay.
But I think they're there.
Oh yeah, I see now. Now
Can
that
you
I
see them?
Yes, it is. Thanks.
All right. Anyway, was that the answer to your question?
Yes, thank you.
Yeah. All right. So if we come over to here, this is the web page that you've all known and loved. If we scroll down, I've made various versions of this, and in the current version, this is how to recognize digits in Python and Google. That's the slides we're currently working on. PPT, those are the PowerPoint slides we're currently working on. That will be the video that we're currently talking in, right? Here, 3 blue, 1 brown. I love him. I watch all his videos. I don't think I've watched this one, but it's worth watching. Then my IEEE talks. So I've given this talk a number of different places, and this is the latest version of it given a couple of weeks ago. So I think you should all watch it because it's brilliantly done. And then the algebra one, I don't think you'll need any of these to do the homework. But you can watch as many of them, right? We'll see what new homework we'll give, or I would hope that you would watch at least the first one, if not all of them, right? Maybe the second one, maybe all of them. And then here's some old stuff, and that's what I got in here so far. All right, so let's go back to this page, and what I've grabbed in here are the real key nuggets from those talks that you need in order to make it through this test question. All right, so it's just saying, I find that machine learning evolves like evolution evolved, and so I think it's way cool. It has lots of cool applications. Did you know that Toronto is getting a self-driving bus?
Yes, we heard that.
Cool, right? Is that cool? There's
That
some
is
negative applications. And now let's just look at the high level of what's happening here. All right, we have a machine that wants to learn to look at images and know whether they're faces or bicycles, right? And the machine is going to learn a neural net like this. It's going to get some image in, and it wants to say face, gets another image, it wants to say bicycle. And we're going to have a supervisor, and she has a huge set of training data, and all the data has been painstakingly labeled probably by some grad student or somebody in India. And what is the machine trying to learn? It's trying to learn the weights on the edges of the neural net, and the machine's going to start with random values there, and he's going to keep changing them, making it better and better. All right, so suppose we have current values on the weights, and we can think about our current value of weights as someplace in weight space. So suppose we had only 2 weights. Of course, we have thousands of weights, tens of thousands, hundreds of thousands of weights, and it's hard to plot that. But so pretend we only had 2 weights, then that can give the machine's location, longitude, latitude, location, right? And so then, given we have this location, that specifies what our weights are, and given our weights, that specifies what our machine does. And so if we feed in an image, it might say it's a bicycle. You feed in another image, it might say it's a face, right? And you'll note it's not doing very well, but well, that's because we don't have very good weights yet, right? And so we give those answers to the supervisor, and the supervisor gives us some measure of how well the machine did, right, on the training data. So, and we're gonna depict that by the height at this location. At this location, we'll have a given height, which will be how well it does on those weights, right? And so then, those weights were great, but we're going to change those weights. And the way we change it is we change them in a way that's going to make our answers a little bit better, right? So somehow the supervisor will help us choose a little direction, and those weights get changed, all right? And so now the machine has different weights. It doesn't have light green weights, it now has dark green weights. So if we put in the dark green weights, then we can then what we do is we feed all the training data through it again, right? We get an image and it says face, it gets an image, it says face. So then we give all those answers to the supervisor. The supervisor gives us a measure of error, and you see the error is a little shorter because it's learned, right? Does that make sense? And so this isn't actually done, but imagine as a thought exercise, suppose for every location that the robot went. We looked at the corresponding weights. We fed all the training data through it. We got an error measure of how well it does, and we put a little height at that spot. And that gives us the error surface. Is everybody with me so far? All right, and now, given I'm standing somewhere, what I'm going to do is I'm going to do steepest descent until I find a valley, right? You're going to just start somewhere and walk down, walk down, walk down. When my son was small, we were climbing a hill, and I said, how do you find the top of the hill? And he says, you just keep going up. And I said, how do you know you're there? He says, you can't go up anymore. I said, dude, you know how to do hill climbing. All right. Now, just as a little warning here, you might think, hey, I'm standing at the top of the hill. Why don't I just look around and find the valley? Right. And the reason is because you have to do this blindfolded, right? Remember, there are thousands and thousands of weights. And so this is a 1,000-dimensional space. And to calculate, given where we are, to calculate anything takes a lot of time. So you just can't look around. All right, that was our little blurb on machine learning. Is everybody good with that? Sinan, you might want to come back because we finished the slides that you've seen already. She came to the engineering talk, so she saw those.
Yeah, slides. I saw these slides and I watched the video again too, actually.
Excellent, excellent.
Yeah.
So now we're moving on to what is affectionately known as Lab 2. Lab 1 goes through all those various examples. I learned Python by looking at everything I know about Python, pretty much. I learned from Lab 1. And now everything I know about machine learning, I learned from Lab 2. All right. So when we finish doing Lab 2, you will then know as much about machine learning and about Python as I do. All right. Right. So what is our goal? Our goal is to recognize digits. So you have to import various things. And remember, so let me just warn you, when you load the page, it's going to give you all the code that somebody else has put in, and it will give you the outputs of each of the little boxes that in the last time it ran, but it doesn't remember, it doesn't know, there are no variables, there's no anything. So if you just go in and run a little box, it will probably not work because it, for example, needs everything. I mean, it needs everything that came before that box, right? So one thing you can do is you can go to the top and do run all. But you might have to wait a while because I think it takes about 5 minutes for it to run. All right. So anyway, you got it. That's their first box. Now let's talk about our training data. Training data is we have a lot of these input-output pairs, right? The X is the input, the Y is the output. And if X and Y were real numbers, then you can think about each of them as a dot, right? There's the X value, there's the Y value, that gives you a particular training data item, right? But of course, and then what are we trying to learn? We have these dots. We're trying to learn a machine that's going to compute the green, and the machine is trying to find a machine that is the best approximation to the purple dots, right? Now, what are our X's? Our X's are images of digits, right? There's an image of a digit. And what is our output? Our output is not a real number. It's a categorization, right? So you may, as a brilliant human, will know that this is a 6. And so this image as as an X will be labeled with 6 because that's the label of that 6, right? Of that image. All right, and so then we run this box here, and what does it do? I guess here, this thing that we uploaded before is I think it's everything brilliant about machine learning is what we uploaded. And here it has some various data sets. And here's a particular data set. I don't know what all those letters stand for, but it's basically, it's our digits, right? So what does it give us? It gives us, remember, these things can return lots of values, right? You call, here's a library of this thing, and you're asking, you're running its program, load data, and it's loading the images for training, the labels for training, the images for testing, and the labels for testing. All right, so the big picture again is we're going to train here. We're going to train on the training data, and then we're going to test how well we did on the testing data. All right, so if you, oh, here I did, remember I said I didn't know how to find the length of a tuple? There it is right there. I'm saying, what's the length of this tuple? The training data contains 60,000 XY pairs. The test data contains 10,000 XY pairs. All right. And this, of course, is our training data, from which we're going to learn, our neural net's going to learn. And what's this? This is our test data, with which we'll evaluate how well our neural net performed, right? And one golden rule of machine learning is when you're training, you do not touch the test data, right? You don't use the test data to learn from. You use the test data to test after you've learned. All right. And then what are images? Well, images are X values like 6. And there's here I'm calling, what am I doing? I'm importing something that knows how to plot, and I'm plotting the training, the 76th training image, right? So training image is a sequence of 60,000 images, and I'm looking at the 76th one. Why? Because it's a fine number. Actually, the lab looks at a different number, and I didn't like it as much, so I grabbed another one. And I think that times -2 flips it from being black and white to white on black. And who knows? We don't need to know all that stuff. All right. And then what are the labels? The labels are 0 through 9. So if we ask training labels is a tuple of 60,000 labels, right? And the 60,000 labels go along with the 60,000 images. So if we look for the 76th image, it's a 2. We look for the 76th label, it happens to be a 2 as well. Everybody follow that? Right? Because it's learning by looking at this image and knowing that this image needs to be a 2. That's how it learns. All right, and then what are we supposed to learn on? I'm going so fast, I'm going to cover all this, everything I've done in the last day and a half. And then what will we do? All right, so all right, we're still talking about our images, our inputs here, right? This is a neural net. And how does the neural net, it's going to have to take that 2 as input. And how does the machine takes a tuple of values as inputs. Here they came, right? That's a tuple of values, right? Well, this, if you look at its shape, it's a square of values, right? We got a square of values that we're trying to fit a square into a line, right? So that's a problem. And so what we need to do is we need to change this square into a line so it fits in. All right. So what are we doing here is we're changing this image is a 28 by 28 matrix of pixels, and we're trying to change it into an array of pixels. All right. So here, training images, I asked, what is the shape of it? All right. What is the shape of it? Well, remember, the training images has 60,000 images in it, and each image has 28 rows and 28 columns, or maybe those are the columns and those are the rows. I have no idea. But anyway, we got 60,000 images. Each image is 28 by 28. All right. And so then we're going to take the training image and we're going to reshape it. We no longer want it to be 60,000 by 28 by 28. We want to be 60,000 by, here, that's the product of them. What's 28 times 28? Happens to be 784, right? So we want to reshape it so that we have 60,000 quote images, and each image is an array of 784 pixels, right? Does that make sense? Am I still with you?
And then what? Like,
Oh.
what then?
Okay, then we continue.
Oh,
Right.
okay.
Then we continue. All right, so that is a square matrix. That is the same number of numbers, same number of, there's a typo, same number of numbers in an array, right? So, so one thing that's interesting is when a human looks at this picture, the human has the information that these two pixels are next to each other, right? And the human uses that information to recognize it as a 2. One thing that you'll note is that the neural net that's trying to learn doesn't have that information. It just has a big array of pixels, and it doesn't know that this pixel is next to that pixel. So there's something, but it manages to learn anyway. All right. All right. So we did that. Right. So now we do something else. All right. So each of these pixels is a floating 32, whatever that is. I guess it's a floating point. It's a real number. And we need to turn it into a number between 0 and 1. All right. So, I guess it's, yeah, I don't, maybe here it's as an integer. So you take it as an integer and you think about it not as an integer, but as a floating point number, right? And then as a floating point number, you can then divide by this to give you a floating point number, right? Because if this was an integer divided by integer, it would do integer division, which would round off, right? But we don't want to do integer division. We want this to be a real number between 0 and 1. All right. So here, the pixel is an integer between 0 and 255. And we do this, and it now becomes a real number between 0 and 1. All right. So now, just as a little note here, I've grabbed various slides that I've made over the years, and I've stuck them in here when I think they're necessary, right? So suppose these were all our x1 values, and these were all our x2 values, maybe, and we're trying to learn something, and x1 is correlated with x2, so you get this funny shape. It just says, if you normalize everything, you get everything to be a nice shape, then it turns these funny ovals into circles, and it makes learning easier. All right. So how do you normalize? Is you find the mean, and you subtract the mean, and you divide by the standard deviation. All right. So let's do an example here. Suppose this is called the normal distribution, right? it has mean, mu. That's mean is the average value, and normal distributions are symmetric about the mean, so that's the mean. And the standard deviation kind of tells you how wide it is. All right, so we want to convert it into something that has mean 0 and standard deviation 1. So these numbers are over there. We converted everything between 0 and 1. Now I guess this will more or less convert thing to be between more or less -1 to more or less +1. But how do you do it? Is here's all our data, right? So you'll see each, right? Our data has lots of x values, right? Here I have 3 x values in my data, and each of my x values has x1, x2, x3, x4, right? And so these the reds are all the x1s, and the greens are all the x2s. So then this is saying I want to take the data and I want to find the mean of everything. And here's a funny expression that I don't know. There are little nuances in Python that it would take you a long time to figure out. But luckily, we steal them from somewhere, and we don't have to come up with them ourselves. So axis equals 0 means that we're going this direction, right? We take, what do we get? What's the result? That's the mean of those numbers, and that's the average of those numbers, and the average, right? This is the average value of x1. This is the average value of x2, right? And then what do we do with it? Is we take the data and we subtract off the mean. Now, I tried to do something like this a few minutes ago and it didn't quite work. But here, I guess, when you say I want to subtract this off, it subtracts it off from each of these. And how does it do it? Right? All numbers, all red numbers went down by this, and all green numbers went down by this. All right. And now we want to know, now if we ask the mean, we do exactly what we did before. What is the mean value of our data? Well, they're all going to be zeros, right? If you take these numbers and you subtract their mean then will be 0, right? So here we took this data and we shifted it so that their means were 0. And then we do the same. We ask for the standard deviation, I guess I'm not doing it for you, but you take the standard deviation. If you divide by the standard deviation, it makes all the standard deviations 1. Anyway, that's a little aside, and you have to do the same for the test data. It's a little aside. And all right, so remember, why did we do that? We did that so that we have nice, clean values that we can feed in as input. Does that make sense? Oops. All right, so now what about the output? All right, so suppose your output, your y value, was a cost. How much something costs. Then 7, 8, 9, they're a reasonably similar costs, and the math will work on them as 7, 8, 9 is numbers, right? But if your y values are labels 0 through 9, then 7, 8, 9 have very completely different meanings, right? 7 is no closer to 8 than 0 is, right? So this is a bad representation. All right. So let's talk about what we want the output of our neural net to be. All right. It's going to input some value 2, and we want it's going to have an output. This node will say this will say the probability that this machine thinks this is a 0 is really low, right? But the probability that it thinks it's a 2 is really high, all right? So the output is going to have one number for each of your labels, right? And what do we want those numbers to be? Well, they're not actually probabilities. They're just numbers this machine is spewing out. But to make them look like probabilities, we want the sum of them to add up to 1, and we want each one to be between 0 and 1, right? To look like probabilities. So when we design our machine, we have to design our machine so that the output looks like a probability. All right. Now, what is the output that we hope for? All right. Up here, oops, the output that we hope for, given this 2, was the digit 2, was the integer 2, right? But we just saw that that's not very helpful for us, right? Instead, what we want the output to be is this array of probabilities, right? So the desired output for this image 2 will be a y value that is this tuple of values, right? So y will no longer be one number. Y will be a tuple of one number per category. And what is the desired output? Well, we want it to say it's a 2 with probability 1, and we want it to say it's a 0 with probability 0, right? Does that make sense? So what we're going to do now is going to convert the answer 2 into this tuple of answers. All right. So how do we do it? Is we take our training labels, and there's some routine called toCategorical, and we're going to change this 2 here. Here is the training label for my 76th image. Remember, it was a 2. We're going to change the label so it's no longer, right? Here I made the exact same call, right? Now it replaced the 2 with this tuple. And what's the meaning of this tuple? Well, that's what the supervisor labeled the image of before. It labeled it as a 2, but we're going to label it with this tuple, and you'll note that there's a 1 where at the second location, right? Are you following this, Shanaz?
Yes, somewhat, yes.
All right, we're just changing the required output 2. The machine learning algorithm is no longer trying to find 2. It's trying to find 0, 0, 1, 0, 0, 0, which is a way of coding 2.
Right.
Right? Does that make sense?
Okay.
And you can see how it might be easier for the machine to do this.
So then the library toCategorical, what is that?
I don't know why it doesn't have a here. Oh, here we go. Here we go. There's this thing called TensorFlow kernel utilities, and one of the kernel utilities is toCategorical, right? So this word toCategorical, you probably could put Bob here, and oh no, I guess toCategorical is one of the routines that's in here, and we're importing it. And once we import it, we can use it.
Mm-hmm.
Right?
Okay.
Does that make sense?
Yeah.
And I think that the future labs, remember I said that there were like 8 labs. I think
Yes.
labs 9 or 10 gets you to write this code yourself. And my leaning is that we won't get you to, I mean, that's more about learning about Python. And I don't care if you learn Python or not. I want us to learn as little about Python as possible so that we can do machine learning. All right. So I'm not going to have you write code for this. All right. So now let's go back to what are we trying to build? We're trying to build a neural net, right? And what is a neuron, right? The neural net is modeling the brain, and the brain has neurons, and the neurons, each neuron fires or doesn't fire. And when it fires, it sends a signal to a neighboring neuron, and those connections have weights. And when enough weight, and that weights, right? If it's a positive weight, then this guy firing is going to encourage that one to firing. And if it's a negative weight, when this one fires, it's going to discourage that one from firing, right? So these neurons are all talking to each other. And when a neuron reaches some threshold, it then fires itself. All right. So let's build an artificial neuron. And you don't need to know this to do what we're doing. Somewhere in your brain, you should know what's happening. All right. It's good for you. All right. So what is a neuron? A neuron is going to take as input an image, right? And here it's taking an image as input. And what is an image? It's a tuple of values, right? And we rearrange it so it wasn't a square, but so that it's an array. And each of these values here for the image is a pixel, and we put all the pixels values into the bottom here. So to make it concrete, here pixel brightnesses of this image, right? We take these pixel brightnesses and we feed them into this neuron, right? That's our input. And then what are we trying to learn? Well, this neuron has weights on all its edges. And what is a weight? A weight is, again, it's just some number. And what is the weight? It says how much does this pixel influence this neuron, right? The 8 says it's influencing a lot, right? But here -2 says that it has a negative influence. This pixel has a negative influence on this neuron, all right? And what do? We take each incoming purple number and multiplying it by the corresponding weight, and we add up. You just add this times this, plus this times this, plus this times this, all added up to give us our Z value, right? And that Z value, in this case, well, there's a ... so you know I'm making it up, might be 18.2, right? And that's the, now we don't know whether this neuron's going to fire or not. That's some number that it's computing, right? All right, so now what do we do with that number? Well, right, each neuron either fires or doesn't fire, right? So we want to return a 0, 1 value. So Y is whether or not this guy fires, right? Right, so a brain neuron either fires or it doesn't fire, right? The picture is either cat or it's not a cat, right? So how are we going to model this? We're going to model by taking this number and pass it through a threshold, all right? So what does that mean? If Z is 18, a big positive number, right? Then Y is going to be 1, right? Because it's past the threshold is 0. And if Z is a negative number, right, then it's going to return 0, right? Does that make sense? It just separate this, that we have a threshold at 0, and if you reach the threshold, you fire. If you don't reach the threshold, you don't fire. And if you want to move the threshold from being at 0, that's what these constants here, right here, W0 is a constant that will move your threshold. All right. And this is called the linear separator for whatever it's worth. And if you look at my algebra slides, I'll show you how to use it. One neuron can do an AND gate, a NOT gate, a NOR gate, a NOT gate. And so if you layer these things, these neurons can do anything your computer can do. All right, because your computer, of course, is just AND gates and OR gates. All right, but the problem with this hard threshold is it's not very friendly for walking on, right? Here are little people walking along here, and remember they're blindfolded. They're trying, so imagine you're sitting up here blindfolded looking for the valley. Are you going to be happy? No, when you're up here, you don't know which direction to go because it's flat. And when you get over here, you fall off the cliff. So that's not very friendly. So what we replace these hard thresholds with a friendlier terrain. So if you were blind and you were standing on the path, you can imagine that you could follow the path downhill. All right, so we can't do hill climbing on this hard threshold. So we're going to replace it with something friendlier like a sigmoid. And this sigmoid, there's the equation for it. It's this pretty little equation. And what does it do? It takes the if the z is a big positive number, then it returns something close to 1. And to be honest, I didn't actually plug this into sigmoid to see what it gave. I faked it, right? If z is a big negative number, right?
Yeah, then it's close to 0, right?
Then it's close to 0.
Right. Yeah.
And here, if z is in the middle, right? It gives us something that's in the middle, right? Does that make sense? All right, so now that is the sigmoid function. And here are brand new slides that Shanaz hasn't seen. I'm doing the same for this rectilinear thing. Why? Because some grad student was doing his PhD and he thought maybe it would work better. Let me tell you what the problem with this is that it's very flat here. And we do machine learning gradient descent by knowing this, which direction it's sloping. And the slope is so small that we won't move very fast, right? And so the advantage of this is here, the slope is big. Oops, here there's no slope at all. But they just tried it, right? You might ask, how do we know what works in machine learning? And what works is people just tried lots of things. And there are lots of grad students sitting in basements hacking and got things to work. And so somebody tried this, and evidently it works better. All right, so what is a rectifier? That is a rectifier in electricity. If you push electricity this way, it flows just fine. And if you push it backwards, then it stops it. All right, so that's what we're going to do. It's a rectilinear unit. I got my letters here right. I had it all small letters, but I noticed it's rectilinear unit. And if you give it a number 18, what does it do with the 18? It keeps it as 18, right? So that's a little against what we were doing before. So it's not a 0-1 firing anymore, right? We're keeping it as 18. And if you give it a negative 18, what does it do? It turns it into a 0. All right. So who knows, but it works. All right. Everybody follow that? Then I, on my own, thought, hey, why don't you do this? So here, there's some slope here, but there's there's lots of slope here, but here's a little bit of slope. And so I made that up myself. And then I saw that other people were doing it too. I wasn't the first to think of that. Right. And right, so that here, now if you bring in negative 18, right, it multiplies it by maybe a tenth. It divided it. Right now, it brings it down to negative 1.8. Right, I just made that up too. All right, so here's some other weird function. Right, maybe it does this instead of that, and this is evidently called the GU.
Oh, that's for the error, right?
No, this is it's still our unit in here.
Okay.
All right, we haven't done errors yet at all. Can you see me all right, or should I turn on my light? I'm sitting in the dark. Hold that. Oh, we're running out of time anyway. All right. I guess we can officially go to 5:30, unofficially go to 5:30. So let's see what we can finish with these. All right, so now we're going to start building our neural net. All right, and here's the code which I copied out of lab 2. And I just kind of myself try to figure out what it does. Here it's saying we're importing an object called models, and we're importing an object called layers. So the model will be, oh, what kind of model do we want? We want our network will be our object, and it will be a sequential model. And so what does sequential model mean, right? That's a single neuron. And what do we do is we're going to layer them sequentially, right? It's sequential, right? There's going to be no cycles. They're going to be layered. That's what we're going to do for our model, right? And then here we'll note, when I did this, I said, right, watch over here, right? There's layer 1, layer 2. Oops, we didn't have that many layers, right? So those, here we're adding, right? We're adding to our network. What are we adding? We're adding layers, right? So here, take your network and add something to it. What are you adding? You're adding a layer, right? And so we only have 2 layers. So let me redraw the picture, all right? So we add this layer, all right? And what does this layer have? Oh, that's layer 1, that's layer 2, all right? So let's go back to our first layer. What does our first layer have? Well, its input is going to have, right, that's actually a product, right? So that's actually not a 28 times 28, right? That's whatever the product is. And they throw these commas in periodically. Maybe Chester will tell us someday what those commas mean, but it's not for me to question.
If you put the comma in, it makes it a tuple as opposed
what?
to just a single value.
Oh, it makes it a tuple instead of a single value.
Yeah.
All right.
A tuple of one value, but it's different from just a single value.
Different from a value. That's there. Good. Thank you, Chester. I knew you could answer. I guess this thing needs to take in as input a tuple. So it's a tuple of 1 values. Anyway, so that's the shape. That's what the input layer is this many pixels, right? And then what do we put inside? Well, our layers are going to be dense. And what does dense mean? It means everything here gets attached to everything here, right? Dense. And then how many outputs do we need in this layer, right? The layer always tells how many outputs there are. This one, we needed to know how many inputs there are, but we need to know how many outputs. We're going to have 512 outputs. And then each of these neurons, what kind of activation unit is it going to use? It says the activation is going to be, remember what that was? That is our rectilinear unit. That's why I made sure I covered it in the previous slides. All right, what are we using? We're using the rectilinear units. So when you're doing your test, you're supposed to try different things and see what works best. So maybe what you could try is you want to know, how does rectilinear units work compared to sigmoid units? So you would have to figure out how to write sigmoid in here. Somewhere you would find that. And all right, so that's that layer, right? Now let's do our layer 2, right? This layer 2. How many inputs does it have? Well, we don't have to tell it how many inputs it has, because the number of inputs it has is the previous layer, right? And how many outputs it has? It's going to have 10 outputs. 10 outputs. Why does it have 10 outputs? Remember, because the outputs are 0 through 9, which tell us what's the probability that it's a 0 or a 1 or a 2 or a 3, right? So we're going to output 0 through 9. And what type of object, what type of threshold do we want here? Well, we want it to be called a softmax. And if I have slides later on, if people want, we can study what softmax does. I think the name softmax is a bad name for it, but nobody asked me. Basically, what it turns it into is it requires that each output is between 0 and 1, and that they add up to 1. The softmax forces it into being a probability, right? That's our layer 2. Oh, did we do that already? Oh, looks like I did that, had that slide twice. And that was it for our neural net. All right, so we've run out of time, and you'll see I have a very few more slides talking about learning. People want to go, should we just zip through these last slides? Anybody? Here, let's just zip through them.
Yeah, sure.
right.
We can just go through them if you want to go.
Let's just zip through them. Learning,
sure.
How do we learn? Well, here's the code I copied from, one thing I wanted to add here. Suppose that you wanted lots of layers here. You want to know how your machine does with lots of layers. You could even put a little loop here that looped over lots of layers, right? Anyway, now what are we doing? We're learning. So here is the code. And I guess what it's taking our network, compile, I guess that's the word for learn all the weights, right? Let's learn. Which optimizer do we use? We're using an optimizer called this. The lab 2 has in the text says that it's a little better than gradient descent. You know, maybe it does momentum, who knows what it does. It's something better than gradient descent. And what do we want our loss function to be? i.e., what's our error function? What are we trying to minimize? Well, this is, I can teach you if you want. This is the classic error message when the outputs are probabilities, right? Remember we have 10 outputs and they're supposed to add up to 1 and stuff. And so this is the classic error for that. And but this is the error that it's going to learn on. But we also want to know what fraction of the training data does it have the right answer for. So this is accuracy, right? So that's doing it. And this isn't learning yet. This is just compiling. I guess it's just building our machine so that it's ready to go. It's compiling our machine. And then this line is doing the actual fitting, right? So we give it the training images, right? What do we got? We're actually learning our neural net. We're feeding in training images. We're outputting training labels. Epochs is the total number of times that you'll pass through the data. So each of our 60,000 training data items will be looked at 5 times. All right. So here we're looking at it's the first time, the second time, the third time. And and batch size, meaning, do you look at all the data before you decide which direction to step? It says no. Look at 128 of the training items and take a step. And then look at another 128 training items and take a step. So these are all parameters that you can play with for your homework, right? Remember, you're supposed to make graphs, which says, right, one graph you could do, which would take you 20 minutes, is you just say, hey, I'm going to try it for lots of different batch sizes, and I'm going to plot batch size versus error, and I'm going to find out which batch size does the best, right? Easy peasy, right? This is how long it takes, running time. This tells us, remember our loss function. You see our loss function is getting better and better, right? Because the machine is doing better and better. And then this is our accuracy. It tells us right after our first epoch, we went through the data once through the data, and it was already getting the right answer on 92% of our images. And now it's getting, right? It's getting it best on 0.99% of the images, right? So that's pretty good. And then we evaluate our network, right? Here we're trying to evaluating it. We're giving it the test images. We give it the test labels and it runs. I don't know if this ... maybe comes out as it's doing it. Maybe it's a timeline. I don't know.
Yeah, it does. It's like a progress bar.
There's a progress bar. Thanks. I haven't run it in a year. So these are I cut out of labs 2, right? How much time it took, what the loss function is on the test data, and what the accuracy is on their test data. And you see on the test data, it's getting 98% accurate, right? So it's getting the wrong answer on 2%. Well, if you go back here, it's doing a little bit better on the training data, right? So another thing I should teach you is about overfitting. If your machine's too powerful, then it does well on the training data, but it does badly on your test data. So if there's a big difference there, then you have to come and talk to me about overfitting. And that's it. That's it. This is about that categorical thing, which we certainly aren't going to cover now. So now, what do you think, Shazaz? That's machine learning. You now know everything about machine learning that I know. Right?
Yes.
And all you have to do is take this code and play with it a bit. And you hand in what you've played with, and Chester, who's our brilliant person who actually works for a living, is going to rank them, rank what people hand in, and give you a mark.
When are these labs due? End of the term or like when?
Well, that's a good question. Let's go over to our calendar, and I'll tell you what I think we should do, though I'm open for discussion, right? Dates. This one says that we were having a test on
Next week.
on Thursday, November 25th, right?
Yeah.
That's a 25th. How long is that from now?
That's next week. So today's Monday,
week, right?
Not this Thursday, next Thursday. Yeah.
A week Thursday. All right. So
Yeah.
my hope, this is what I want to do. I want to, between now and a week Thursday, we will keep talking about it, right? Between now and next Wednesday, I'll have my code up and running. So you can run my code and we'll go through my code and see how it works. And I think you can modify the code and have something going between now and a week Thursday. And then we have 2 more weeks until we do it again. And my thinking is that the first one is going to be all regression, where the output is a number Y. And then the second one, we'll do it again, where the output is categories. And that is what I think. What do you think?
So my understanding is that by next Thursday, you want the first lab to be done?
A week Thursday.
Right, a week Thursday, right, on the
Yeah.
25th. And then the second lab to be done by the week after that. 2
Oh,
weeks
is it
after
1 week
that.
after that?
2 weeks after that.
Yeah, 2 weeks after that. And then we go home.
Oh, no, that's actually 1 week after that.
Is it 1 week after?
Yeah, wait, test 6 Wednesday. So
Yeah,
so
the
then-
25th is 1 week from the 2nd.
Yeah.
Definitely 1 week,
but
definitely
then
7
it
days.
says test 6 is Wednesday, December 8th. So
Oh, yeah,
then-
and we moved it. Why? Because that's our last day of class.
yeah.
Anyway, this is all flexible. If people feel it's too hard, then we can deal with it. But I would say that between now and in a week Thursday, you should have at least taken my code and changed something.
Do we want to do something maybe more objective in terms of ranking? Because the TA doesn't know if he can rank people to things based on ambiguous criteria.
Which TA would that be, Chester?
Chester.
All right, well, let's I will produce my code between now and Wednesday, and we will look at it and we'll think if we could make it more objective. But
yeah, let's try to do something objective so that everybody can know how well they're doing, and the TA can also know how well they're doing.
yeah. So here, I'm personally kind of fascinated with this. I want to know, suppose my function is e to the x. Can a machine learn e to the x? Can it learn?
Yeah, I know the answer to that one. The answer is yes.
It can, eh?
Yeah, well, within a finite range, right?
So it must cut it up. It must cut it up into blocks,
Right.
and then do a threshold for each block. or
Right. You can
something,
learn
right?
it within a finite range unless you model it with a function, right? So if you
Right.
model it to something that doesn't have the power to do e to the x, then it won't be able to do e to the x.
Right.
But if
So
you give it
anyway,
something that can, then it can.
so this is, we could limit, if we want to limit the range here. What I want to know is how well can it learn functions, right? So the homework will then make up your own personal function, or maybe a couple functions, and see how well it does on them, right? I'm not going to run it on e to the x. Here, Shanaz, let me tell you what you should do. You should take my code and run it on e to the x and see how well it does. My plan is to run it on various polynomials.
Mm-hmm.
I'm going to try, I want to try it on x squared and x. So the one, remember there are two homework assignments. The one is
Right.
you run it on x squared and you plot how well does it do on x squared. And then the second one is you have a series of things. So I was thinking about having a parameter, say r, and running it on x to the r. And then I was going to plot r versus how well does it do for different r's.
Wow.
Right? I don't know. Try it.
Yeah. I think we should try it.
Right? But you
Yeah.
can see I'm not asking you to modify anything. You won't have to modify much of the code, right? You'll
Mhm.
find where I have the function. You'll find where I'm trying different things. I don't
Yeah.
think it'll take much to modify. And if you come back on one of the days and say, I want to modify the code to do this, I could help you, we could write it together, right?
Oops.
Everybody good with that?
So Professor, just one thing. So lab 1 is filled with examples, and I think there's no application in it. So do we start where, so this actual submission lab, do they start from lab 2?
No, you've missed the big picture. We have today, right this minute, in this hour and a half, we did everything in lab 1 and everything in lab 2. They're done.
Right, exactly.
And lab 3 and 4, I haven't looked at yet, but my memory from last year is they ask for heavy Python coding and like write the code for the categorizing, right? Rewrite that code. And I don't think we want to do that, right? I don't think this is not a course in learning how to write fancy Python code, right? So my suggestion is that unless Chester convinces me that the other labs are interesting, my recommendation is we drop the remaining labs. And what do we do instead is we basically take, I'm going to take lab 2, that, what does it do? It recognizes digits. And I'm going to change it so that it recognizes the function x squared.
Mhm.
right?
Right.
And then it will drill little plots to see how well does it recognize x squared? How long does it learn x to the r for various r's? I personally find it a fascinating question. I would love to plot it and see, we plot it and does it become a little step function, right? My bet is we'll plot x squared and then we'll plot the machine and we'll see how the machine is approximating it with the step function, right? Because ultimately the machine is still kind of thresholds, right? I don't know. I don't have the answer to, I don't know. I'm curious to what it's going to do. And I'm hoping you're curious too. And so we'll just try it.
Sure. Okay.
Right?
Thank you.
How do you feel about that?
Well, it makes sense. And yeah, let's see, I guess.
And I say all the time that tests are easy and then they're hard for you. But in the end, you do okay, right? I don't think anybody who shows up to class hasn't been thrown under the bus yet. What do you laugh about that? Have we thrown you under the bus yet?
No, this is a very happy smile.
All right, good. Right? So
Yeah.
I think it'll be fun to play with this,
Yeah.
right? And then
Yeah,
you
this
can say,
looks like fun stuff. I like
then
this.
you can say, hey, I did machine learning, right?
Uh-huh.
I think actually Lab
students-
3 is interesting as well. It was
Is
a
it?
different problem on the housing market, on housing prices. That one was
All
pretty
right.
interesting. If you want, I can probably swap out all the places to write Python code and put in the code there. So it's just to run it as like
Right.
Lab 2.
All right. Oh, so it's learning about housing prices.
Yeah.
Great.
And
Right.
it covers keyfold cross-validation,
Right.
which is kind of a useful thing to know if you have a small data set. So I
Right.
think that's also useful.
Right.
Lab
so
1, the rest of them you can probably skip. But yeah,
Right.
I'd do 3 as well.
Okay. As I said, I haven't looked at them in a year, and all I do is I remember writing the categorical one and trying to get the students in Africa to write this categorical code, and
Well,
nobody wanted
I think
to do
it's an interesting learning exercise to write it. But you know,
it. It is if you were taking a Python course.
No, as a machine learning thing, because
Is it?
it's one thing to just call a function and you get back the things as one values, one hot vector.
Right.
But then how do you do that? How do you actually come up with that?
Right.
You have to go through the
Right.
process finding the max, and then you can then know where to put each one.
For sure.
Yeah, it's not a useless exercise in my opinion.
For sure. And I do have slides down here. If we go down, here's me trying to teach it to people in Africa. So if really people, we could try to do that if we wanted to. All right, we done for the day?
Yes, I guess.
All
Mhm.
So
right,
the final verdict is I plug in the code into Lab 3, right?
what?
I should plug in the code into Lab 3, all the parts that are missing code.
Sure, sounds good.
All right,
Yeah,
I'll do that.
let's try Lab 3. Yeah, let's teach them Lab 3. So some of you, like Shanaz, I hope I will see at 5 o'clock
Tomorrow.
on
Yes, tomorrow 5.
Tuesday.
Yeah,
And
that's tomorrow.
then some of you I will see at 10 o'clock on Wednesday, and then on 4 o'clock on Wednesday, just because
Right.
you don't get enough of me.
Mhm. Yep.
All right. Any last thoughts?
No.
All right. Then there are 9 of you. I just don't know how. Yeah. All right. I talked to 9 of you, and that's okay. So just think, Shanaz, if you weren't in this course, how lonely it would be for me, right?
Yeah.
All right. I will see you all when we do.
Okay. See you tomorrow.
Bye, Chester. Thanks for your
All
help.
right, no problem.
Hey,
Thanks,
Chester, what
everybody.
did you
Bye.
think about how did you think that went?
Yeah, it was good. I think it was good.
Good.
It's more important what they think, but I think it was good.
And what about you, Shanaz? Did you follow that?
Yeah, I did. I think it was pretty good. Yeah.
Slides are pretty good, eh? We just
Yeah,
bang, bang,
they're-
bang, bang, bang.
Yeah, slides were good. Explanation was precise, you know. So I think we'll all be fine. Yeah, we've done 1022, so yeah, I think it should be all right. Yeah.
Yeah, yeah.
Yeah.
Alrighty. See you tomorrow.
Okay. See you then.
Right,
Take care.
everybody. Bye.
Okay.